Welcome again. This is Troubleshooting with Retrotec. We're going to do live questions and answers. We're going to do, I haven't seen anything on the question panel. So it looks like, okay, thank you, Mr. Nelson. So Mr. Nelson, the first man in. Thank you so much. So it looks like that's working. Everybody can hear me. I think it's time to get started. So what I'd like to do is first start sort of similar to what we normally start with, but tell you a little bit about other sort of reference sources. So I want to make sure that you understand that this isn't your last chance to learn any of this information. And if there's additional questions that come up, or if there's additional ideas or anything that kind of comes up that you didn't think of yet, our quick guides and manuals on the Retrotec website are always a great reference source. In fact, it's pretty much our wiki or our encyclopedia of information that's directly related to or indirectly related to testing using Retrotec products. So again, that's available on retrotec.com. Let's start with, actually, if it's okay with you, we've got a question already, so I'd like to address it. So the question is, let's see, I'm going to read this verbatim. If you've got three 300 SR fans, one of them still has 15 to 20% lower pressure than the others, and the question is, what can I do? Colin, do you want to answer that question?
Yeah, I already answered it in notes. So there's a bunch of things. Usually we should deal with it on a one-on-one basis, but there will be a difference of about 3-4% at least in every flow pressure. Could be 10. But a 10% difference in flow pressure is only 5% difference in flow, and that could be tip clearance or it could be a bunch of things. There's also a speed adjustment on the front panel of a 3000 fan on the new ones, and you can adjust the maximum output, so someone may have adjusted that, so it'll be something to look at.
Cool, awesome. Very, very useful. Does it help you out, Mr. Ott? Does that answer your question? Okay, well, let's talk a little bit about, let's kind of go, I don't know, kind of a basic chronological approach to testing. So let's talk about some of the things that you can do to problem solve or troubleshoot before the trouble even starts. As many of you know, or some of you don't know, the DM32, which is our newest gauge, that actually only needs to be calibrated about every 5 years. And the reason for that is it can update firmware right online. Right now, the most current version is 2.2, and that's a build 49. So if your DM32 is not up to date, if that isn't the same build or the same version, then just update it, plug it right into to the gauge configurator, and that will that'll check online to make sure that it's up to date. So that's the first thing you want to do. You want to make sure that you're using the most up-to-date software. All right, and I'm just checking to see if there's any more questions. Any questions about that? Observations? Has anybody had? And I should mention, I'm not sure if I mentioned before, but it's not just questions. If you have any insights or any sort of tips or tricks or best practices for the rest of us, please use your question panel for that too. Okay. So the next thing you want to do is make sure that that you actually field check your equipment. So as you can see over here on the left, let's see if I can actually get this guy over here. So right there, pointed out, that is an excerpt from one of our quick guides. And if you haven't used or seen one of the quick guides yet, basically the quick guides they come with all of your equipment and they're available online at retrotec.com. But you'll find these will give you a really good idea of how to do your test. And this is one of the pages, the last page, that kind of talks about the field check for calibration. So this particular field check, let's go into kind of how we do that. So let's talk about the gauge first. So your gauge, and any gauge, any digital gauge that you have, I should say, of the 2 or 3 that are currently on the market, has 2 channels or 2 sides. And for us, the DM32 that you're looking at here, you have an A and a B. So those 2 channels, the only thing that those 2 have in common, those are 2 differential pressure gauges. They are unique and the only connection that they have is power, but they have no physical connection beyond that. So what you can do is actually take one of your pieces of tubing, and plug it in. This is the same piece of tube. Plug one end into channel A and one end into any port on channel B. And this is commonly known the port-to-port test. So what you'll see on your gauge, if it's set for pressure on channel A and pressure at channel B, is that they both should be about 2%, or within, they should be about the same readings within about 2%. And here you have a different configuration where we're plugging into a different port, connected to a different port, and so on. And you'll notice that here we are testing our yellow cords, and here we're testing some blue or some red cords. And the point being that not only we're not only testing to make sure that our gauge is calibrated or in calibration if you're a rater, but we're also making sure that our tubes don't have any holes or cuts or any kind of problems. Any questions about that? So let me finish this next slide. So again, the idea is that both channel A and channel B should be within about 2%. That shows you that your gauge is working. And if they don't drop, if you get any sort of rapid drops in pressure, that usually means that the pressure that you built in the tube when you plugged it onto the ports is being released, and that usually means that there's something wrong with the tube. So if that's all right with everybody, I think we have some more questions in here. Joe or Colin, do you see any questions that you want to field right now?
Yeah, there's a couple of interesting questions in there that I could, they're a little technical, but I could attack them right now if you wanted.
Absolutely, please.
One is Michael Nelson, who was asking about an accuracy issue if I daisy chain all the interior reference tubes to one point in the building. I use the extra DM2s to verify the pressure around the enclosure. Actually, you have it a bit backwards there. What we want to do is we want to pick up separate pressures inside the building and have the same pressure on all the gauges for outside the building. So we don't want to find out how the pressures are different outside the building. We want to accumulate them all together and pull them all into one. So what I recommend you do is to run one tube through the building, tee that off as often as you need to. So you might have a tee and then a 50-foot piece on each side. If you need to get a better averaging, if your baseline is bouncing around too much, you may want to tee that off again and put another two 50-footers on the end of it. Usually the first one is enough. You move that around until you get the baseline pressure in the building, across the building, moving as little as possible. And then you take that tube, which will normally be a red tube if you're inside the building, and that red tube is common to each channel of your gauge. So we're commoning the reds, or we're commoning the outdoor, but we're running separate tubes to different places in the indoor because we want to see how the indoor pressure is different. We need to measure those pressures to a common base, and that common base we establish by, again, manifolding or teeing all of the red tubes together. And then inside the building, we'll be running blue tubes at different parts of the building. If we're standing outside the building, it's all reversed. The red tubes will be going through the panel, and it will go to inside the building. And so it's the other way around. We have some really nice drawings in our multi-fan manual to show exactly how to do that. So that would be the first question. And the other one that's going to take me a while to read, so why don't you just take it back there, Jay.
Okay, sure. We'll definitely get to the next question. So yeah, Colin, if you want to take a look at that next question, I'll go through a couple slides and then we'll bring it back to you. Is that okay? Okay, he's got his mute on, but I'm sure it's okay.
Yeah, I turn my mic off when I finish talking, so then it takes me a while to turn it on and say yes and turn it back off again.
Yeah, maybe we should ask a question about, maybe we should work on something that's a calibration, a mic calibration or something. Maybe we could hook up our microphones to Fantastic or something. It might work, automate it. But, so I hope that answered your question. We definitely need to get to the next question. But first, let's talk a little bit about, let's go back to sort of the calibration method, if that's okay with everybody. Okay. Well, let's talk about calibrating your door fan now, and I will talk a little bit about calibrating your duct tester. So I guess I shouldn't say calibration is not a exact. This isn't exactly what we're doing. We're checking to see if it's in calibration, and I like to use that because that's sort of a radar term. But what we want to do, so if we want to check our fan, what we want to do is start with sort of any small room in the house. It's usually much better to do an office or any small room. And what we're going to do is set up our fan sort of as usual, but you'll see that there's something a little bit different here. And what's different here is that we've taken a flat object. In this point here, I believe that's OSB or a press board, but you can use corrugated plastic, or you can use cardboard, whatever you want to use, as long as it's sort of strong enough to and can easily fit into this part of the door. So what we've done here is we've actually installed our panel and frame about halfway up the door, and then connected it directly to this piece of this flat object, this plane. Now what we've done here is we've actually cut a square into this piece of, here again it's a piece of wood, but it could be any flat object, and we know exactly how big that square is. So what we're going to try and do here is that we're going to try and make sure that we're going to measure it. We're going to actually run the fan. We'll run the fan once with this covered up, and we'll get leakage, and then we'll run the fan again. And the next time that we run it, we'll be looking at on our gauge. We'll be looking at equivalent leakage in square inches, or for those of you who are that use metric system, you can also look in. I believe is it centimeters, squared centimeters, or squared millimeters? Sorry, I'm a terrible American. But either way, now what we can do is we can run the test once to get the leakage with that hole covered up. And that hole, we know exactly how big it is. Then we run the test again, and we deduct the first test, or the test without the open hole, from the second test with the known hole. And that should be about the size of the hole that we cut. So here's the 20 by 20 inch hole, which is about 400 square inches. So the equivalent leakage on the second test should be about 400 square inches larger than the first test. Does that make sense to everybody? Well, great. I'm going to leave this up for a second. Colin, do you want to address that second question?
Yeah, well, not that one. I'm still reading it, trying to figure out. But there was a question specifically on the hole. Okay. People say, oh, gee, why not put a round hole? Well, there's a really good reason for putting a round hole in. Very few people can get the area measurement right. Pi r squared, just doesn't do it for most people. So big advantage of square is that it's easy to measure the area. Even then, it can be tough to get it right. So that's the main reason. It's easier to make. It's hard to make round holes. It's easier to make square holes most of the time. I measured a difference between a square hole and a round hole cut on a flat plate, and I actually could not tell the difference. So I'm not seeing a difference. It's certainly probably less than 1%, so I'm going with square holes. Back to you, Jay.
Thank you. Yeah, just as long as you don't try and get a round peg in that square hole. So we can also do this pretty much almost the exact same principle we can use for our duct testers. And here we have a calibration plate. So this is something that we sell. It's the same principle, like I said, as the blowerdoor duct test. Here there actually is a hole that we made. I don't know, it's sort of a great segue from that last question. But here's a hole, and it's pretty simple. You just set up the duct tester as you would as if you were attaching to a return in a house. But here we attach it to the duct tester, to the calibration plate, and you can see here that right here that we have our blue hose, or our input hose that's connected right here to the plate. So we've run our blowerdoor, and this is a known hole of a known size, and we just calibrate or see if our fan's in calibration for that. Now you can do a sort of a DIY method that is almost the exact same same idea as the fan, the door fan, where you can actually add take our flange with the Velcro or mechanical fastener and attach it to a piece of rigid flat object, just like the one that we put into the door in the last example. Cut the hole of the size that you want, just like the last one, and just make sure that you tape it around the sides. You'll see even here with the calibration plate that we have that taped around the side. There's our usual typical red flange on the other side, but so that we don't get any additional leakage, so that only this area is what we test. So does that make sense to everybody? Any questions about that? All right, so Colin, are you ready to address this verbose?
I'm still reading it. Somebody did ask another question about the plate. Yes, it is much better to use something other than cardboard, masonite, plastic, whatever. We have a hard enough time getting people to do it at all, let alone doing it out of some nice material. Yes, it's better not to use cardboard, but the thing is, people have access to cardboard. They can tape it in the doorway and throw it away when they're done, and they can cut it with a razor knife. And we're just trying to get people to do it, period, just to see that it works. And if a person has a problem with the equipment, one of the first things to do is just to check it with a field calibration plate. And you can do the same thing with a duct tester as well, just to see, you know, is it my duct tester, is it my blower door, what is it? Is it reading right? Often we have someone that will do a test with one piece of equipment and another, and they'll be out by 40, 50%, whatever, and they'll say, well, which one's wrong? Well, by using the field calibration plate, you can usually figure out which one is wrong. And I don't know whether you mentioned or not, Jay, but we can actually measure these holes in equivalent leakage area, so we can measure them directly. We don't have to measure them in CFM. I personally think that CFM at 50 or CFM at 25 are silly units. I think that a hole size and area is a much smarter unit because it's something you can actually see. Like that hole there, I think is 18.6 square inches. Well, you can understand that. But 129 CFM at 40 pascals, how big a hole is that? Who knows? Back to you, Jay.
Good point. Yeah, if I didn't mention it earlier, I do want to mention that one of the great things about the DM32 is that it can give you all kinds of results right in the gauge. So you're not tied specifically to just CFM or pressure, Pascal usually. So here what we actually did was instead of testing for pressure at flow or pressure at CFM, we're actually going to test for pressure at equivalent leakage, and you can do per square inch, you can do per square centimeter, but the point is that, like Colin said, when you cut your hole, if you make your own hole, you could cut it 10 by 10, and then you know that you should have an equivalent leakage of 100 square inches or centimeters. So that is, and I completely agree that if you're not testing to a specific code or some kind of specific standard that means that you have to use that, it's probably easier to understand. Joe, was that you? Did you want to chime in?
Very, very good, savvy of you, Jay. So one of the things I wanted to ask is what kind of gauge do our listeners have, if we can get a quick feedback? We chose not to do a bunch of polls that are kind of limiting, but just kind of, it is a question and answer. So if you could chime in as to what gauge you have, DG700, DM32, DM2, it doesn't matter if you have Wi-Fi or not. But for those of you that do have the DM32, the thing that Jay is referring to and Colin about how to get your leakage area, that if you make sure we're on the same page, if you go to your settings and it actually allows you to determine what results you want. You can also pick that from channel B, and it starts off with pascals and CFM, and then a flow area, CFM per 100 square feet. And on the next page, if you go to the bottom right-hand corner and select the dots, there's a whole nother laundry list of additional options for you. In the very top, it actually has your leakage per square foot or square inches that don't actually have any additional pressures in it, and that's the easiest way to use this method. Thanks, Jay.
Thank you, Joe. Yeah, that's, You know, one of the things that I'm learning about this format, I guess we're all kind of figuring this out together, is that it's tough to come up with visuals as these questions come up. So I hope everybody is okay with sort of these the verbal explanations of solutions. But yeah, so it looks like again, Joe was asking what kind of gauge you're using. Are you using a DM32? Are you using a DM2? Are you using a DM1? Are you using a DG700? Don't be ashamed. You can tell us if you're using another manufacturer, the Energy Conservatory, the only other manufacturer. Is anybody using a Magna Helix gauge out there? I would love to hear that. So great, I'm glad to see that we've got a lot of people who are using DM32s, probably half DM32 and half DM2, almost exactly right down the middle. All right, so and then Colin, just let me know whenever you're ready to answer that big question. I'm going to move on, and let's talk a little bit about when you're testing. So here's some of the things. So we talked a little bit about just getting prepared to test, but let's go through some really basic things that we can, some basic solutions for some of the problems that we hear quite a bit about, or I'm sorry, obstacles that people run into. Sorry about that, Joe. So let's talk about some of the desired results. Say if your desired results are not achieved. So here what we're talking about is we've actually got to pressure. So you can see I'm testing a duct at 25 pascals. So I'm at pressure, no problem. And here in the top left corner you can see that my fan speed's at about 55%, which is perfect. But I'm getting these two little dashes. It's not a zero. It's not like we're just completely lacking. We're actually getting two dash marks. So that must mean that I'm not having problems. So I'm not having any problem getting to pressure in whatever I'm testing here. It's a ductwork, but it could be a house, could be a shell, it could be a component, could be a piece, a manufacturing piece that you're working on, whatever it is, but I'm not getting any flow through it. So what I want to do is I want to add a flow range or a ring, depending, or even a plug, depending on what model you have. You want a more restrictive hole. So the point is that the way that the gauge works is that the gauge is it's a calibrated gauge, and it's going to compare an unknown hole to a known hole. Now that unknown hole is something that is the leakage that's in whatever, the duct or the house or the building or the window, but the known hole is this thing that's right on the front of the fan. So essentially we have brought that space to pressure very easily without moving much air. So without that air moving through this hole, we're not getting any readings across our fan or any kind of pressure drop. So we want to add this restrictive hole so that we have a smaller volume of air being concentrated through there so that we can get a reading. Does that make sense to everybody? Does anybody want me to explain this a little bit more? Is this a common, or is this a problem that you've run into and you still don't know how to traverse it or a solution for it? Okay, sure. I'll explain a little bit more. So we have here we have a channel A. So on the top we have channel A. So this is, I'm sorry, I should show you. This is a screenshot from the DM32. The top reading right here is from channel A. So that's a reading from channel A. That's a pressure. That's a pressure that's in the house. Or I'm sorry, in this particular example, it's in the ductwork. So I have reached, I reached 25, and this is my fan speed. My fan isn't really isn't working that hard, so I have pretty easily reached pressure. But I'm not getting any reading at all in channel B. And channel B is telling me the amount of flow, a CFM. That's the amount of flow that's going through the walls of that ductwork. But the problem is, in reality, that ductwork is so tight that there's not enough air moving through the fan for the fan to physically pick up or to physically register an amount of flow. And it sounds like one of my cohorts here might want to jump in and make this a little bit more clear. Joe or Colin, did you guys have a comment that you wanted to help explain? So the point is that, oh, so I'm sorry. Yeah, so the point is that I've added, and I'll show you again in the little schematic here, we started with an open range and there wasn't enough error to get a reading. So what we've done here is we're going to add a more restrictive range, a plug, that's going to make a smaller known hole for us to compare with the leakage, and also going to give us take some of that very small volume of air and concentrate it through the fan so that we can get a nice reading. So hopefully that makes sense. I'm going to move on. So what if sort of the opposite happens? What if we get flow, but we cannot achieve pressure? So again, here we have, I'm at full speed. My fan is, as we say in the music industry, my fan is completely dimed out. It's all the way up to 11, right? So, but I still can't, I'm getting a flow, but I cannot achieve the pressure. So we can try the opposite. We can try to actually take off one of the restrictive plates, one of the rings or ranges or plugs, depending on your fan, and so that you can get a larger volume of air moving through there. So again, that plate, that ring, the configuration that you had with the plug, that range is actually impeding or making it so that you can't get a huge enough volume of air through that fan. So you just take that off. It could also be the case where, simply enough, you just have a window open, or there's a piece of duct mask that has blown off. That happens a lot when you're forced to pressurize a duct or duct system. And then of course we could also do this if we're pretty close to the desired pressure. And again, in this example it's 25, but it could be 50 or 75. We can always just use this sort of at pressure button. And that at pressure button, when that's on, that's going to say, well, you're at 20 pascals, but I will give you this reading right here as if you were at 25. Does that make sense to everybody? Any questions about that? All right. Joe or Colin, did you want to address one of these questions that we've had typed in?
Not yet.
All right. Excellent. So, everybody pretty comfortable with that? Anybody who asked, for those of you who asked for me to explain a little bit further, are you feeling pretty comfortable? All right, can we move on? Okay. Well, here's another issue that we have quite a bit, especially right here. We're going to talk a little bit about our reference tube placement, and sometimes with the duct tester, it can actually be the input as well. But we have a problem sometimes with a reference tube placement, and simply put, oh, thank you. I'm glad we're ready. Simply put, this is a pressure gauge. A manometer is a differential pressure gauge. So it's always telling us the difference between 2 points. It's not telling us absolute pressure. It's telling us what the difference between 2 points is. So oftentimes we only concentrate on the input, that the tip of the tube that goes into the area that we're testing, but we forget about what it's referenced to. So in this picture, you have a picture of me placing a reference tube out of the way. So I'm going to explain to you a little bit why. So here again, in this fan, and I know that some of you have seen this slide before, so don't ruin it for everybody else. But let me ask you: is this okay? Is it okay to set it up like this? And Mr. Otto will definitely answer your question in a moment. But let me put this question out to you: is this reference hose okay? Oh, great. So yeah, it is definitely not. And for those of you who answered, you're exactly right. So here's sort of a best practice that I've kind of put together. This is my opinion. This is not the official opinion of Retrotec. This is not a piece of equipment that you can purchase for us, nor is it a piece of equipment that we endorse. It's just one that I put together myself at home. And basically, right, this fan, you see that you have this fan flow. This is the back of the fan that faces the outside of the house, and it is blowing this way, and that air can blow directly into my reference tube and give me I want to say, I guess felonious is not a good word, can give us fallacious or incorrect readings. So what I've done here is I kind of built this thing at home. So I just took this old sort of, I think it's a dishwashing liquid or clothes washing liquid, or I don't wash my clothes enough, I guess. But I took a tube, pressure tube, put it in there, and then I took this tennis ball, I perforated it, I put a pressure tube into there, all the way in there, filled it up with some rocks, then I actually buried it under some rocks in here and put a cap on it. And now I can tell you that I've used this many times. Probably, I don't know, several hundred times in all kinds of different weather. And I'm talking to you now from Chicago. In Chicago we have extreme hot, extreme wind, we have extreme cold. I've used it in all those different types of settings, and very rarely have I had any problems with pressure fluctuations or wind induced fluctuations on that probe. Joe, did you want to mention something?
Very savvy of you. Can you also clarify that you actually have perforated the whiter outer shell of what everybody sees? Is that correct?
No, it's not. This actually, it does have a hole that goes through right here, and then it's got a little hole around the ring, but actually did not perforate it. So this is definitely not airtight, which is good. Which is Joe's point. It does not need to be airtight, which is exactly why I actually only perforated the ball here. But the top of it's not perforated. And the point being that that we're still allowing, if that case, I can get all kinds of Venturi effect, I can get all kinds of wind moving across it, I can get wind blowing into it, I can cause all kinds of causes of problems that I'm trying to avoid. And it does work. I will say this as well. There are people that recommend that you put it into a manometer case, or that say, oh, well, you can just sort of bury it in a bottle. I've tried those two, and that definitely doesn't work. If you've seen pressure affect a brick house, then you know that it doesn't work on a piece of fabric, piece of cloth. Let's see. So, any questions here, Joe, that you see that you want to talk about?
No, I do want to have one. Yeah, go ahead. Go.
On the picture you showed, I picked on you last time when you showed this picture, but you show the tube elevated in the air and hanging from the hand railing. When that happens, that tube will oscillate back and forth and create quite a bit of pressure, even if there's not very much wind. So you can figure that out yourself just by taking the tube and waving it back and forth while it's attached to the gauge, and you can see that. So it's always important that the tube is in a stable position so that the tube itself is not moving, because when it does, the flexing of the tube will create pressure. The picture that you show has got the open end of the tube, which can be blown into, which is another kind of pressure altogether that is being picked up by the tube end, which is the velocity pressure. So did you have another related comment to make on this, Joe, or should I talk to?
No, I had the identical comment. So, and you beat me to it. So yeah, go ahead.
So maybe on that slide you should say, don't do it like this, but put a red line down on the ground where the tube should go. So a couple of other questions that people asked. I finally got to the big question I read through, and I figured out what Mr. Hermans was asking. And he's doing a multi-point test from 10 to 100 pascals. Very fastidious, I'm sure, way of testing. In Europe, the maximum pressure that you can test at is 100. The minimum pressure you can test at is 10. And so people think they're supposed to go from 10 to 100. They're not. They're not supposed to go below 10, which means you don't have to go to 10. And you're not supposed to go above 100. Most of the results you're looking for there are at 50 pascals. You'd probably get better results if you tested from 40 to 60 pascals than going over that wide range. although testing over that range does identify a few problems that might be going on in the building, so it does have some value. I seldom suggest that we test at 10 pascals. We have defaults in our new software for each of the different standards. Usually they're around 20, 25. One of the problems that you run into when you test over a wide range, it almost forces you to change flow ranges. And when you take the time to change flow ranges, testing conditions can change, and that will cause a notch in your results. And whenever you change ranges, there's always a little bit of difference between one range and another. And when you do that, you always throw the results off. So it looks like there's an advantage in testing over a wide range. In fact, there isn't. We make our ranges very, very close together so that there's a lot of overlap between gauges. Not all manufacturers do that. Most of them just have maybe a few percent overlap. We have like 60, 80% overlap. So you do have the ability to test an entire test in one range, which I think is a better idea. I would say for the kind of test that you're doing, if you tested from, let's say, 30 pascals to 60 pascals on a regular basis, if you're looking for results at 50, you would consistently get more repeatable results than testing from 10 to 100. So there's my point there. And I'll go on to answer another question where people were asking about, oh, somebody left. Oh, I'll answer it anyway. He was asking why his DM32 with the at pressure button doesn't always show 50 pascals. The at pressure button has will show the pressure that you're set to. So if you set to 50, it will show you at 50. You can also change the default at 50, and using the set speed button, it will always go to that default. So I'll read the next question while you carry on and talk some more there.
Okay.
Wait, wait 1 second. I want to clarify. Sorry. Is that the only time that it shows up is when you are telling the gauge to perform a test, either with at pressure or at speed. So you actually can perform a test using the speed control on your fan. But if you want to use the at feature, then I actually have to engage it either doing the test or thinking that it's doing the test. So I can actually use my duct tester or blower door with the speed control on the side of the fan. And the only way that I can do that is if the speed control is disconnected. Because if the speed control is connected, it makes the gauge control it. So I can read all my pressures, but if you want to get the add pressure, you can still say, you know, set pressure, and I can now actually do any pressure I want. So if I could run my blower door with the speed control knob up to 50, but if I wanted to read it at another setting, I could actually tell it to, say, set pressure 25 or 75, and now I could actually be reading that with the at feature, and I can kind of do both with able to move around what the gauge options are. If hopefully that makes sense.
Does to me.
So we've got another question here. It looks like a bunch of people from Germany. That's great. He was saying that his software told him to change ranges in mid-test, which actually brings up a really important point. Whenever you're doing a multi-point test, let's say you decide you're going to test from 25 to 75, go to the range you think you're going to be on, go to 25, go to 75, make sure you can get a reading. If you can't, you already know in advance that your software is going to tell you to change ranges. I remember I looked at a test once and the person changed ranges 5 times because they went to the very lowest range and then it ran out of juice and then it made them change ranges and so on. The test took forever. It's a really important idea when you're doing a multi-point test to take all of your test points on the same range, and it takes much, much less time when you do that. So that would be the first point. The next point is when you do change ranges in mid-test, what you have to do is you have to add that range on this little plus button down there. So you'd be taking data, let's say in your case on C1, you're going to change to C2. So you add C2, and then your data now goes into C2. So you might have missed that test. And whenever you do a test with our software and you have a problem with it, make a copy of the file and send the copy of the file to us, the data file, so that way we can repopulate your test and we can make corrections and send them back to you. Back to you, Jay.
I think we're supposed to go back to Joe and then Joe goes back to me, but we'll skip the protocol. Hopefully that's okay with all of our friends out there. But so quick question. So about this slide, and then we'll move on. But I've got a couple questions here. One was about why I did not perforate the white box. And then another question is why do you use the mud and the stones? And essentially, the mud and the stones were part of the evolution of this actual piece. As you see, this is kind of a dirty, that ball is actually dirty. Initially what I used to do is take a garden trowel, which is, you know, just a small hand shovel, and I'd cut a hole in the earth about 6 inches deep, drop the ball in there with the tube, with the reference tube connected to it, and then I'd put the dirt back on it. So that's how this thing got dirty. And then I had a friend, a coworker, that said, well, instead of digging the hole every time, why don't you just sort of make your own hole and then enclose it and bring it with you. So that's how I did that. As far as the perforation is concerned, remember that we're sort of differentiating here between different. Well, I guess I just used the word twice. The differential pressure gauge is not giving us, it's not giving us the sort of the atmospheric pressure. We live at the bottom of an ocean of air, and there's a heck of a lot of pressure from that air. So in the region that I live in, the sort of the earth content, well, that pressure is still very much that pressure that we're referencing is still very much alive at up to a few feet underground, and with no exception of this sort of flimsy plastic container. So all this container is doing is stopping any kind of direct wind or direct air movement, but it's still referencing. You're still going to be referencing the same pressure, that atmospheric pressure that's outside the house, as you would if that hose was laying out in the open and was, but it was a calm day. So somebody have a point about that? Okay, so I'm going to move on to this next slide. Let's see. I'm sorry, I'm just taking a second to read these questions. So same sort of, this is the same concept for duct testing as the one that we talked about again, but here we're not talking so much about the reference as we're talking about testing pressure inside of a duct. So here's just want to differentiate, that's the word of the day, differentiate between a pitot tube with static pressure probe, which Joe told me earlier is pretty much, this is the one that we see quite a bit of. It's very uncommon that you'll see just a standard or just a unique pilot tube. And then a static pressure tube or probe. The static pressure probe is the one that we include with our duct systems, our residential duct testing systems. And the reason for that is, as you can see, that these actually have holes on the side, whereas a pitot tube or the pitot and pressure tube has a hole in the middle and on the side. And the problem with this is, if there's air moving through a duct system, we don't want that air going directly into the tube and causing pressure fluctuations again. So what we want to do is we want to test pressure without that sort of volumetric flow actually pushing through there and causing and giving us readings that are not correct, that are not regular pressure readings. Does that make sense to everybody? Okay, so any other, Colin or Joe, did you want to talk about anything, answer any questions?
Yeah, someone was asking about the add exponent feature and how it's determined. In the old DM2, you were entering the n value, and it was one of the variables. And in the more recent or the earlier versions of the DM32, it was the same way, which caused a lot of confusion and so on. And ducts are set for an n of 0.6, and houses are set for an n of 0.65, and whole flow and flow grids are set for an n of 0.5. What we did on the new version is based on the device that you've set, it would set the N value automatically, so it was transparent to you. You never have to worry about it. So I hope that answers your question there.
All right, so we've got a few more minutes left here. Oh, excellent. So you're welcome, sir. So we've got a couple more slides. I wanted to talk a little bit about, now that we've sort of discussed some common obstacles that happen before testing, how we can avoid them, and some of the obstacles that happen during testing, let's talk a little bit about how we can improve our process. And these are sort of some general ways that we can use the DM32. And this is Wi-Fi specific, so you can, I guess, sort of attempt some of this stuff using the DM2, because a lot of this process improvement stuff is based on just general off-the-shelf technology. But a lot of what we're talking about here is sort of based on the DM2, or DM32. I'm sorry. Is that okay with everybody? And so point is that here you actually have a picture of me, and this is pretty much me doing the same thing that I'm doing right now, except for I've got a hat on because it's still cold in Chicago. And what I'm doing here is I'm actually connecting to some people in the house who are using a DM32, and that DM32 Wi-Fi gauge is connected to a computer. They're using a piece of software, a free piece of software from Retrotec called Virtual Gauge to connect to the DM32. And they're using, they're connected to the internet, and they're using a screen share piece of software that is connected to me here. So the point is that if you have staff members, or if you're training people, if you have other people who are dependent or that are not nearly as savvy, or even people that you're consulting with, you can have them, they can get out in the field, they can be testing, and they can use you remotely as a trainer or as a supporter. Now you could also be actually doing quality control, so you could be checking on someone. Say if you were a building official and you wanted to check or to view witness a certain amount of tests, you could potentially use this software to be in several places. Just here, standing at your office, you could contact several people from around the world and watch or witness their test, potentially. Just so you understand too, Joe actually made this. Joe, this is available at this website. I don't believe this is on our retrotec.com, but this is a real quick one sheet about how to do those sort of screen shares and those hangouts, those live web conferencing type of things for free. And Joe's got that available as a step to how to, and there's an email about how to find that.
Yeah, that is still there, and that is case sensitive if you're typing that down, so that is a case sensitive link.
So are there any questions? That basically completes the material that we had. We got about 5 minutes. If there's any other questions that anybody has, anything you want to add?
Yeah, there's a couple there, Jay. They're kind of interesting. One is a follow-up on the N value. What the heck is the N value? Well, something you don't need to know about unless if you need to know it, you usually know you need to know it. But different holes have different amounts of turbulent and laminar flow, and that's determined by the N value. So ducts tend to have a little bit of laminar flow through the leaks. Houses have a little bit more, and so on. That's kind of all you really have to know, but how it's used is it's the extrapolation value that takes you from your test pressure to your reference pressure. So let's say you're testing at 25 pascals, that's all you can reach. You got your fan running wide open, you can't get any more out of it, but you want a result at 50. So it says you're at 25 and you're blowing 5,000 CFM, but at 50, you would, if you could get there, you'd be blowing 7,800. So I'm going to say 7,800 at 50, even though you're only measuring 5,000 at 25. Does that make sense? I'll just pause a little bit there and let it sink in. We have another question about what's the maximum area that you can measure with a fan. And of course, that's with the fan running wide open, and our fans run around 55,500 CFM, that kind of thing. Let's just call it 5,000 CFM for the sake of argument. So a really easy equation for you to remember is that CFM is equal to the square root of the pressure that's being created times the area of the hole in square inches. So if we're establishing a 25 Pascal pressure on a 1,000 square foot hole, that's 5,000 CFM. So you take 25, you ask yourself, what times what equals 25? 5 times 5 equals 25. Square root of 25 is 5. 5 times 1,000 square inch hole size is around 5,000 CFM. There's a little bit, it's a little bit more. It's about 7% more than that. But just for kind of easy figuring, it's 5,000 CFM. So if we were trying to test that at 50 pascals, the square root of 50 is 7 point something. 7 sevens are 49, close to 50. 7 times the area is 7,000 CFM. So it's going to take us 7,000 CFM to test a 1,000 square inch hole at 50 pascals. So those are all the questions I can see.
Yep, thank you. And thank you for that easy to remember formula. For those of you who just are using a Magna-Helic gauge, you can definitely just sort of do that stuff in your head. Or you can just use a DM32 or a DM2. But yeah, so
Andrews was asking a question about the red reference tube. I'm not 100% clear on what the question is, but maybe I can just say something that might clear it up. The red reference hose is the one that runs through the panel when you're inside the building, which you are most of the time. And you want to basically get a pressure that is going to be the same whether the fan is running or not running. So it's your reference pressure. So what you're trying to do is you're trying to change the pressure inside based on that reference pressure. And the pressure outside tends to always be the same no matter where you are. Yeah, it might be a little bit higher or lower because of the wind, but basically the pressure outside is created by the weight of the atmosphere, and it's pretty much the same. Well, it is exactly the same on every side of the house. So what you want to do is put the tube in an area where it's not going to be affected by the wind blowing on it or by your fan creating some kind of pressure. So I like to take it away from the house, 5-10 feet or so, and my solution is just to put a flat piece of 1/4 inch plywood over top of it. 1 square foot is fine, just to stop the wind from blowing in the end of the tube. And that's usually what you need to do as far as the red tube is concerned. Now, some places where it rains a lot, you really want to make sure you don't get a drop of water in the end of that tube. So there's a bunch of different ways of doing that. Just do something or find a method that works well for you. The proof of the pudding is you take a look at the gauge once you've got your fan set up, and you just look at the pressure with the fan shut off, and if it doesn't fluctuate more than 1 or 2 pascals, you're fine. If it fluctuates more than 2 pascals, you want to move it farther away from the building. You want to move it to a different location. You want to put a T on the end and maybe run 2 25-foot tubes off either side. Anything to kind of balance that, that wind pressure off. We have a section in our manual on tube placement. I can't actually remember what section I put it in, but it's in there. And if you have trouble finding it, let us know.
thank you. So so at this point, you know, our regular webinar is over. Of course, we are opening. We are open for additional questions, and sort of that's been our format up to now. But for anybody who's getting ready to leave, who needs to move on, we just want to say thank you so much. And I think Joe has another comment.
Yeah, I found the math slide in case you guys didn't notice that I put that up there. So that is up on the screen right now. And I can tell you about the next webinars that we'll have coming up for the next 3 weeks.
Oh, yeah, please do.
We have a couple more questions here, and I'm happy to say that we've got a few people from Europe this time. I guess we must have sent the email blast out to them. So happy to have our European friends on board. So very interesting. So that's why we're talking bilingual here, because we deal with a lot of European customers. So there was a question about that formula in metric. So if you could just whip one up and throw it up on the screen there, Joe, that would be great.
Yeah, that would be, yeah.
I'm sorry, but we don't have one to put on the screen right now. Mr. Hoff, if you send me your email address, I'll do the conversions for you and fire it off to you. My apologies. So, yeah, there's another question here about the number of fan calculator. Will it become a part of Fantastic? I think that's what you're asking. We actually have the number of fan calculator on our website as a separate software program, and there's a different number of fan calculator for large buildings and for enclosure integrity testing. They're both there, and you can download them. I've also given instructions to our website guy to put a units conversion calculator on there as well, so we can convert from many imperial units, which we have to apologize continuously to the people in Europe for these silly units that we have over here. So we're still running through a whole lot of metric conversion. So we understand maybe another 100 years we'll get that straightened out. It looks like maybe we should have like a calculator on our website along with the formulas for these flow calculators, these flow calculations that people want to do. So
I'm not going to say no, right?
You're not going to say no? Does that mean say yes?
Yeah.
I got 3 people that want the European.
Yeah, let me. I want to just mention too. residentialenergydynamics.com. It's all one word. residentialenergydynamics.com. You'll actually find a whole host of conversions, both in metric and imperial, for all kinds of stuff. So I highly recommend taking a look at that.
We should have had a survey and find out how many people were from Europe here, because I got 3 people from Europe asking me for this this formula. So this is great.
Joe, do you want to talk about webinars?
Yeah, I do. I can tell you what they may not be up on the website just yet, but I can show you what our next webinars are. So next week, you can come right back at same day, same location and time. And Cullen will be your host. Jay and I are kind of on the road or should be traveling at that time. So we're actually working on a feature to our website that kind of helps people out there that are testing. So there's a variety of different types of testers that are out there that Cullen has been working on. So I thought that I would throw that out there and we could talk about, he would talk about, maybe I can support him from the road on what are some other ways of test methods that people are doing and are using to actually increase their business model. So we'll talk briefly about other things you can do with your duct tester or blower door as a powered flow hood, how to do a total flow of your air handler, or actually use your duct tester for exhaust or supply flows. It's a very phenomenal tool that many people have and don't realize you can expand that. There's several things about enclosure zone testing, from area of refuge to raised floor or control areas, and Cullen will have a few pictures and kind of overview. Our goal is to kind of give you an overview of some other options that are out there for you, and some water penetration testing. Again, some people may or may not add the water to their testing method, but our goal is to give you an overview and how these can actually help your business model. The week after, we're going to get back into blower door testing 101, which is kind of a fundamentals of blower door. We did this last week, I believe, with duct testers. So it's mostly about, are you testing for the energy code or envelope performance? What are some basic do's and don'ts? We'll talk about, again, placement of your tubing. This is a universal concept for many of you that are have come back from Europe, we always enjoy you to be part of our audience. I know in the past year we actually had a lot of people joining in from Europe, and it's dinner time over there for many of you, or even later. So that's definitely a great overview. The one after that is a hot and common topic that I'll be addressing, and some nice 3D graphics. Leakage to outside. What are some optional test methods? I'm not sure if this actually comes up a lot in Europe or not, but here in the U.S. it still is part of some codes, and Energy Star and third-party programs use this. So we're going to go through the different methods and comparing A to B, pressurization, depressurization, trying to test to 0. So that takes us up to pretty much near almost the end of the month, and there will be more to come. If you want to know more, you can definitely go to the Retrotec website and see our list of webinars. So that's definitely the place to go. Colin, anything else for you?
No, I'm still furiously writing down all these email addresses we have here.
Oh, you can copy and paste them too.
This one. Copy here?
So the webinars I just mentioned will be here on, if you go to retrotec.com, and at the top you can find support. And so under support gives you a variety of things that Jay's mentioned today, from the manuals and guides to software to webinars. And this is the place to go or to keep track of what we're doing. I'm good, Jay. Back to you.
All right. Well, I think that's everything. Are any questions that we missed? Anything else that anybody wanted to talk about?
Okay, don't close down the webinar just yet, because
Okay.
I just figured out how to, there's a feature on here that allows me to copy an email address from the chat window, so that's pretty cool.
Yeah.
Didn't even know that. It actually plucks the email address out of the text.
Wow. Interesting. Yeah, and just again, let everybody know if you're looking for those, for any of those conversions, or if you're looking for any other kind of really cool calculation tools, that's residential energy dynamics. I posted it in the chat window, and I posted it on the question board. Okay. Well, thank you so much. Let's see, if you have an intermittent door problem, a blower door is a fantastic tool, not for measurement, but to create the smell. Oh.
Odor problem. Yeah, he says that you can recreate an odor problem that may or may not. So that could be a funky drain or a funky rodent that kind of comes and goes depending on the wind or the direction of the wind. So that's a great tip. Thanks.
Yeah, thanks so much. Okay, well, we're going to sign off, and
I'm still copying down email addresses, Jay, so I'm still missing one here. I'm slow.
It's okay. We can create you a report that has all those in it.
I think I've got them all. 1, 2, 3, 4, 5. Yeah, I think I got them all now. Okay, so I'm good to go.
That has them, so just make sure you got them correctly.
Yeah, I think we got them all.
all right. So as we began this webinar with a little view behind the veil, we also will end it as such. Thanks so much for joining us, especially those of you who are missing your dinner to be with us. We really appreciate it. As always, we really, really appreciate your time. It means a lot to us that you've taken away from your busy day, from your personal and professional life, to spend some time with us, and we hope that it was helpful. We'll see you again next Tuesday. Thank you.